Okay, number 3 here is called perfect estimation skills, and this is a really fun one to perform. Now, I recommend that you have a high card value at the bottom before you begin this. So you can do that in a number of ways as you show the cards. King is ideal to have a king at the bottom. You can just kind of casually switch those so that you have a king, if you didn't already, have a king of any suit at the bottom, and you'll see why. Okay, so if you start with a king at the bottom, it actually makes things easier for you as the performer. Okay, so what this looks like is, it looks like you're just randomly cutting a block of cards and then just using the weight of the cards or the thickness of the cards or your training with the cards, you're somehow going to be able to perfectly state how many cards are in that randomly cut packet. Okay, so that's what it looks like to the spectator. Now what you're going to do is a little bit of mathematics to figure that out. And so how this works is, if I randomly cut a portion of the deck like this, okay, and I pretend to kind of go, I wonder how many cards are here. I do need to catch a glimpse of the bottom card. Now ignore the suit, which is kind of nice actually. Just focus on the value. Okay, so I just need to spot that that's a 5. Okay, so to state the exact number of cards here, what I need to do is I need to know the bottom card, which is a king, so that's a 13. And then I need to spot the bottom card of the packet. So for my variables here, just to point this out, the D represents the value of the bottom card of the deck, the whole deck, which is 13, it's a king. P represents the value of the bottom card of this packet that you've randomly cut, which is 5. Okay, so that's what the D and the P represents. So all you need to do here is take those two values and subtract them. So 13 minus 5 is 8. Now that number needs to be multiplied by 4. Okay, so 8 times 4 comes out to be 32. So 32 is what we get so far, 32 for that calculation. And then from there, you may have to do an adjustment to that number depending on just common sense evaluation of how many cards you think you have here. So we got 32 out of this calculation. Looking at this, do you think there are 32 cards here, when indeed there's 52 in the whole deck? Well, no. Half the deck is 26. This is far less than half the deck. So what you need to do is you may need to either add or subtract 13 from the computed value here. So right now we have 32. So if you subtract 13, you get 19. So there should be 19 cards here, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We nailed it. It's exactly 19. Now, if you notice what I didn't reverse count. I'm not changing the order of these. I'm just counting them while maintaining their current order. We do that so that you can now set this on top. You can perform a random cut if you would like, though I guess that's going to affect your king at the bottom, so maybe don't do that in this particular case. But we can repeat what we just did with the perfect estimation skills. So why don't we go ahead and cut off a big chunk here, more than half. Okay, well that looks like more than half, not a lot more, but that's probably more than 26. Okay, so I need to spot the bottom. Oh, we see a queen. Queen is 12. Now remember, the bottom card started out to be, quote, a 13, a king. So we need to take 13 subtract 12, that's 1, right? So 1 times 4 is 4, okay? Do I have 4 cards here? Certainly not, right? Now we need to add 13 and then kind of reassess. 4 plus 13 is 17. Do you think I have 17 cards here? I don't think so, right? This is right around half the deck. Well, if 17's not right, then we need to add 13 again. So that would give us 30. So apparently we have 30 cards here. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. We nailed it again. There are exactly 30, okay? And when you go to count those, as I did here, it is effective to slow down the counting at the end because it kind of heightens the anticipation of the spectator. They're thinking, there's no way you got that number exactly. And so as you slow down the counting of those final cards, they're going to go, it added up. He got exactly the quantity of cards that were randomly cut. Okay, so why don't we do one more? We'll do maybe a smaller one. Okay, so this is very, very small. What's the bottom card? It's a jack, which is an 11. So the king, 13, minus the jack, which is 11, leaves us with 2. 2 times 4 is 8. Does it appear that we have 8 cards? Well, the alternative is that we have 8 cards plus 13, which would be 21, which is almost half the deck. We don't have anything close to half the deck. So it looks like it will, in fact, just be 8. 1, 2, 3, 4, 5, 6, 7, 8. And it is. Okay. So I will probably leave it as an exercise for you to see if you can puzzle through why this formula works. And I think as you work with it, you'll develop an intuition for what's going on and realize, oh, this is exactly what you need to do. Of course, the 4 is here because of the suits, cycling through, right? And the 13's here because of the card values, cycling every 13 positions, okay? And then I have this note over here. You may have to add or subtract 13 more than once. And we saw an example of that where I had to add 13 twice. We got a number of 4. Remember, we got a count of 4 over here because we got a 1 and then times 4 is 4. And then we had to add 13. We got 17. It was more than 17 cards, so we added 13 again, and that bumped us up to 30. And 30 was the right answer for that packet. Okay, so that's called perfect estimation skills, a really fun one as well, and pretty surprising for anyone watching it.